Hi, welcome to the Olympiad geometry. Let's continue our study on Excenter. Before we start, if you think this video is helpful, please click the like button, comment, share, and subscribe the channel. So here is a problem. The incircle of triangle ABC is tangent to BC on D. DE is diameter of incircle. AE meets BC on F. Prove that BD equals to CF. So when we get this problem, the first thing that we want to check on is that BD equals to CF is equivalent to BF equals to CD, right? And what is CD? You can think the CD as that we find the incircle of the triangle ABC, and we find the incenter. So we connect the incenter and the tangent point, which means that the incenter, which means that OD is perpendicular to BC, right? And we find the tangent point, and then we capture the distance of the CD, that's from the tangent point to a vertex. So this actually reminds us that we learned it in the property of the excenter, that this distance equals to the distance. So if we find the excenter of the angle A, right? If I draw this linear, okay. About here. So if we find IA here, and we find the projection point from IA to this line BC, and we know that CD equals to this distance, right? The projection, let's call it G. So CD equals to BG. Here we want to prove that CD equals to BF, which means we want to prove that G and F are the same point, right? And based on this knowledge, we can transfer this problem to the following problem, that the incircle of triangle ABC is tangent to BC on D, right? This doesn't change. And now let's just say that we find excenter IA, projection to BC on F, connect AF, meet, connecting AF meets circle O on E, and prove EO is perpendicular to BC. Right, these two problems are the same. So I would like to choose this one to prove because it's easier. Why it's easier? Because we find the excenter, and we find the projection point, which means that we get a perpendicular relation here, and we just need to prove another perpendicular relation, right? It's easier than directly to prove that BD equals to CF, okay? So this would be easier, and let's just think about how to prove this one. We already know that here the G is F, right? I'll just replace to this one. And here we just think about how can we prove that EO is perpendicular with BC. We already know that IAF is perpendicular with BC, so we need to prove it equivalent. So EO is perpendicular with BC is equivalent to IAF is in parallel with EO, right? Because IAF is perpendicular with BC. And IAF in parallel with EO, this point is F, right? That's the same point. Just want to make sure that you note this one. So IAF is in parallel with EO is equivalent to that EO to IAF equals to AO to AIA, right? And what is EO? EO is the radius of the inner circle, and IAF, that is the radius of the X circle, which means we already know the relation, we know that RA equals to R times cotangent angle half angle B cotangent half angle C, right? We introduced this in the property of the excenter. So we know this relation already, which means we get that R, which is EO, to RA, which is IAF, equals to tangent half angle B tangent half angle C, right? Then the problem is transferred to that we want to find out AO to AI and prove that AO to AI equals to this one, right? And what is AO to AI? AO, AI, AO, AI. So just look at this figure. It may be kind of difficult, but if you remember that in the Excenter property, we introduced that the ABC, the triangle ABC, is actually the pedal triangle of the triangle IAIBIC, right? So if I draw an equivalent figure here, it would be like this one. I need to draw the circumcircle first because I will need to use it. So let me just draw it here. So see, this is IA, this is IB, this is IC. Then we know that this point would be A, this point would be B, and this point would be C, right? I use a notation in this figure to represent in this figure. I just draw the circumcircle of the IIBS, you know, it's too large here. And this point here, we call it O. O is incenter of triangle ABC, and O is orthocenter of triangle IAIBIC, right? That's all we learned before. So let's connect the triangle ABC. So what we are looking for is AO to AIA, right? And you see that O is the orthocenter of triangle IAIBIC. We already know that AO equals 2. If I extend IAO meets the circumcircle of triangle IAIBIC on another point, let's call it O prime. Then we already know that AO equals to AO prime, right? So this one equals to AO prime to AIA, right? AO prime to AIA, which equals to the area ratio of the triangle IBAO prime to the triangle area IBAIA, right? And it equals to half of BO prime, IBO prime times IBA times sine angle O prime IBA 2 half of IBA times IBIA times sine angle AIBIA. Right, that's so this one is the area of the triangle IBO prime A, right? IBO prime times IBA times the sine angle O prime IBA. That's this angle. And for the triangle IBAIA, we use IBA times IBIA, half of IBA times IBIA times the sine angle AIBIA, right? And this equals to, see, IBO prime. Here, this one cancel each other, right? So we have IBO prime to IBIA. So if you look at the triangle IBIAO prime, then IBO prime to IBIA equals to sine angle IBIAO prime, right? And we write down the other term here. And for IBIA, so IBO prime to IBIA, IBO prime to IBIA, that represent for this angle. So sine angle IBO prime IA, that's a sine law, right? And times sine angle AIBIA. Okay. Now we just need to figure out this term and this term, whether they are equal to each other, right? So what is angle IBIAO prime? IBIAO prime, this angle. We know that IACOB, these 4 points are cyclic, which means angle IBIAO prime, this angle equals to angle CBO, right, equals to this one. And we already know this is half angle B, so it equals to sine half angle B, right? And what is angle IBO prime IA? IBO prime IA, this one, it equals to this one, angle IBICIA, right? And we know that angle IBICIA equals to 90 minus half of angle C. So this is a sine 90 minus half of angle C, right? That's for the angle IBO prime IA. And what is angle O prime IBA? O prime IBA, this one. That's actually angle O prime IBIC equals to angle O prime IAIC, this one, right? And we know this one equals to this one because IACOB are cyclic. And this is half of angle C, so times sine angle C by 2. And what is angle AIBIA? Angle AIBIA, this one. We know that angle AIBIA plus angle IBIAA equals to 90 degrees. And we know that this angle, the angle IBIAA, equals to half of angle B, which means this angle is 90 degrees minus half angle B. So that's sine 90 degrees minus half angle B. And it's obvious this is cosine half angle C, this is cosine half angle B. So this term is tangent half angle B tangent half angle C, right? And based on this, we know that AO2 AIA equals to R2 RA, right? Which means AO to AIA equals to R2 RA, right? That means EO is perpendicular to BC, right? In parallel with IAF perpendicular to BC. And we just prove it. Okay, so for this problem, this is the easiest way that I can think of. Maybe there are other solutions more elegant than this way. Welcome to share it with me if you can think of. But this is the easiest way I can think that, because it's so straightforward that we want to prove that BF equals to CD, and we already know the equivalent amount of the CD, and we can translate it from proving that CD equals to BF, and the F point we find it from the diameter. So all of this we translate it to that we find the Excenter first and find the projection point, and then we prove that EO is perpendicular with BC. These two problems are equal, right? If this is true, this has to be true. So, and based on we want to prove that EO is perpendicular with BC, which means that we want to prove IF is in parallel with EO, and then we can find that we want to prove that EO to IAF equals to AO to AIA, and all of these can be written to based on what we learned, right? Okay, that's it. I hope you like this problem. I hope you like this video. See you in next one. Thank you.